Hi, I'm Paul Ricketts with the South Physics Observatory again. Today we're going to show you how to set up a very basic German equatorial mount. This one is likely around 15 years old and has a few additions to it, but the companies these days are selling versions of this that are a little bit more updated but are basically about the same. A lot of them are based off of this exact style. So we're going to go through how to set it up for your observing session and trying to figure out anything good from it. Okay, so first of all, what we want to do is get it tall enough for us to actually use. So we want to release or bring these out all the way. Depends on your height. If you're a little bit shorter, you might want to go a little bit farther down. Make sure they are fairly tight, but not too tight. That way you don't pop through the thin metal on them. And then, once you get that, you want to orient this with this axis, this hole to this hole, facing north. You want this right here pointing up. You want it at an angle that matches your latitude here on Earth. We are about 40 degrees, so you would want to put this at about 40 degrees, and that'll be pointing towards the North Star. If you have it backwards this way, then all of your rotation that you're going to get from this is going to be completely backwards. So you got to make sure that this is pointed north. On this particular one, there is a label on it here. Can you see that? There's a label on it here for north, so that kind of gives you an idea that it should be facing that direction. Okay, so that's about north for us. We're not going to go crazy with it right now. So we'll figure out the next step. So we're going to start off using the counterweight bar here. We're going to put that onto the telescope here. Okay, so I'm going to insert this right here. And it's got a lot of threads on it, so it'll take a second. And you want to make sure it's fairly tight on there. That way it doesn't want to wiggle when you're moving around. Before you actually start putting anything else onto the telescope, including the optical tube, you want to finish setting up the tripods. This particular one has a spreading bar, what would you call this, tray. This particular one has a spreading bar tray, and we're going to put that on really quick. What this does is it helps to keep the tripod from wiggling quite as much as it would otherwise. So you just want to get that in here, and it's also a great addition for storing your eyepieces and other things, so you don't have to go very far to find them. You want to start them just a little bit loose so you can move it around a little bit still. And get those legs lined up just right. And then you can tighten them up a little bit more. And that just helps to get the legs a little bit more stable. Good? Okay. Now, assuming you have a level either on its own or one built into your phone, I have one built into my phone, so I'm going to use that one. You put your level anywhere where it is fairly flat, and then what you want to do is notice the direction of tilt and either raise or lower your legs to get it level. So you want to do this that way when you're tracking across the sky, it's tracking across the sky properly. And you may have to do this nearly every time you set your scope up. So the closer you can get it, the better results you'll have later on. So I'm 0.0 and 0.1 off, so I'm going to call that good for now. So one easy way to get this angle situated for your location here is just to use another app on your phone that can help tell you your angle, but you only can do this once you get your base leveled. If it's not leveled, this will be off. Okay, so using an app, you can kind of get pretty close on it. Down here. I'm going to use these adjustments here. We're going to move it up or down to try to get it down to about 40 and a half, at least for my position here on Earth. You'll have to loosen one and then tighten one, and then again both tight once it's good. Okay, so next we're going to put the counterweight on. You always want to be sure to do this before you put the optical tube on. Otherwise the optical tube is going to be way heavy here. It's going to draw this down, and you actually may hit the legs with your optical tube and damage that or the mount itself. And make sure this is on there fairly tight, and you're good to go there. Okay, so next we want to put the optical tube into the saddle here. This one actually has a special one that was made for this old mount, so yours may not look exactly like this, but it will work or function similarly depending on, or pretty much for all of them. So you want to loosen up your saddle, not all of the way so it doesn't fall off, but enough to be able to fit your dovetail on. So this is the dovetail right here. I call it a dovetail because it looks like a woodworking dovetail. So you take that, keep it in your hands the whole time, slide it in place, about right there, tighten things down. Don't let go until you know they're tight. There you go. So this type of telescope you can get fully manual. You can also get a little tracking motor with a battery pack on it. That makes it a lot easier later on when you're trying to show it to other people or stare at the same object for more than a few seconds. So this particular one has a single axis just because it's so old. Some newer ones have a dual axis that you can buy for it, and it'll track in RA, but it'll also give you a little bit of functionality for going up and down just with buttons really slowly, so you're not shaking the telescope when you're moving it. So next what I'm going to do is, since the eyepiece holder and focus are all the way up here, I'm going to release this just a little bit and turn the entire telescope so I can actually see the focusing mechanism right there. And tighten these back up just a little bit. So now before I do any balancing, I also want to make sure there's an eyepiece in there. This one, it doesn't weigh very much, but some eyepieces do weigh a fair amount. So you want to have that in there, or all of your other equipment on, before you actually do your balancing. And make sure you tighten your eyepiece up so it doesn't fall out. Good. So now what we need to do is balance the telescope with the counterbalance here. If it's too heavy on one side or the other, what's going to happen is it's not going to be able to track effectively, or it can even burn out motors or overdrive motors. So you want to make sure that it is balanced properly to make sure none of those problems actually come up. So what we're going to do is I'm going to release the right ascension lock, and then I'm going to just see how far off it is in balance. And that one is way far off on the balance. So what you want to do is relock and move this up about halfway, tighten that down, unlock, and then check again. And if it drifts one way or the other more, or seems to stop faster in one direction or the other, then you'll have to rebalance. So let me show you how that works just a little bit more. So if it's really close, you'll see it kind of still wants to drift. You can move it up just a little bit at a time. And you see how it kind of tips back just a little. Go up just a little bit more. See how it wants to stop a little bit faster in that direction, and then that one. So that means you're almost there, but not quite. A little bit more. Should be good. So then you'll kind of see it has the same stopping ability in both directions. So then you'll put it back like this and lock it up, and then we'll move to the right or the declination axis. Okay, let's do that one. Ready? Everything's still focused. All right. So for this one, we're going to check the declination axis, just because if you are using a telescope that has a motor in the declination axis, you want that balanced also. And even if it's a little bit unbalanced up here, it can throw your tracking and stuff off a little bit down here too. So we're going to do that. So in that position, you just want to do the same thing. Move it back and forth. So it seems like it's a little bit heavier in the front than it is in the back. So then you relock. Loosen your dovetail here. So if it's loose, or if it's heavier in the front, you want to move it backwards just by a little bit. Relock those, loosen, and then check. So now it feels a little bit heavier in the front still. So we'll go back just a little bit. Sometimes if you're running out of room on your dovetail, you can actually move the telescope itself back. That's what I'm going to do on this one. I'm just going to pull the telescope back just a little bit. Be careful, making sure it doesn't slip out and fall on the ground. Okay, now we'll check it again. Now it seems just a little bit heavy in the back end. So lock that. Now you can move your dovetail back one more time. Check it one more time. Now it's pretty good right there. Alrighty. That's how you balance your telescope. Alright, next we're going to check the collimation of the telescope. I'm going to be using a LaserMate Deluxe 2 just because this is way easy. And it has the little bullseye to reflect the light, and so you can see it off to the side. So I'm going to mount that right in here where we can see it. Tighten those up. I'm going to turn it on. And you can kind of see the laser right there, which means we're not very far off. So we're going to pop this open. Put that off to the side. You can look right in the back and see the little circle back there that is the center of the mirror. So we want to adjust the secondary mirror to be able to get the LaserMate laser right into the middle of that. So using these, this is a 2mm Allen wrench. I'm going to just adjust these ever so slightly. If it's too tight in this direction, that means you want to release in these directions. And then you can tighten a little bit more there. Loosen here. Tighten there. And then it looks like it's really close to being right in the center. Might be off just a little bit on one side. I'll get it as close to the middle as possible for best results. So now we're going to adjust the primary mirror. It's pretty close already, right in there, but I'll show you how to move it. But getting it right back into the center of the laser is your goal. So we're going to move the primary mirror around to be able to do that. That's likely dead on right there, as close as we can. Okay, so we're here out in the middle of the night almost, and we're gonna use our telescope that we set up earlier today to attempt to look at some objects. Probably going to choose Venus over here in the east. Maybe see if we can pick out Mizar and Alcor pretty easily, and then maybe try something a little bit harder, especially in this light polluted area. Maybe try for the Whirlpool Galaxy. It's going to be hard to see that, so we probably won't, but we can try. So first thing to do, since we don't have a finder scope on here, and usually you don't really need one anyway if you have the right kind of laser, but we can use this laser, shine it through, and hopefully we can pick out where it's pointing in the sky. There we go. So we can check out Mizar and Alcor by pushing this guy around. If you're using a telescope that has a computer motor drive, you don't want to push it around like that because you'll lose your positioning. But on here, it's perfectly fine. So now that I'm there, I'm going to turn on our tracking. That way it stays with the object. I'm going to kill that light for me. And then we'll see what we can get. Okay, something's in there, so I gotta focus. And there it is, Mizar and Alcor. So you can use fine adjustment here to go up and down, and the hand paddle to go left and right. Or you can kind of push it around. So this is not a very high power telescope. You can still see Mizar and Alcor, and notice that it is not a single star or even a double star. So that's one cool thing about it. How's that? Okay. So now that we've seen Mizar and Alcor, we can point over here to the west, and we can see Venus. And even through a small scope like this, you'll be able to see it pretty well. This one is actually going to be pretty easy. You just move the whole telescope like that, and go to the other side with the laser. Point it into the eyepiece. Right there. And then we're going to look. If it's in an awkward position, the cool thing about these little Newtonian telescopes, you can loosen those, turn the telescope so you can see it better. And you won't lose anything from doing that. So look in here. And there's Venus. It's not very magnified because I don't have a very powerful eyepiece in here, but it still looks really bright. So I'm going to center it up just a little bit better. And I'm going to try to take a picture with my phone. See if we can get a video of it. There it is. Bright Venus right there in the middle. And it's that easy moving one of these around. So now we're going to try to go to the Whirlpool Galaxy. Still filming?
Yeah.
So if you use, I kind of know where it is, so you can use a map to figure that out. I'll show that on another video on how to do that. It's going to be somewhere in there. Let's see if we're lucky enough. A lot of light pollution, but still a fair number of little stars out. I'm going to slew around a little bit. Well, probably won't be able to see it because it's a little fuzzy up there, and it's hard to see it even in a 14-inch telescope, but it was always fun to try. There should be somewhere in this area. Oh, there it is. Tiniest little smudge that looks like a star, but it's a smudge instead of a star. And there's M3. Can't take a picture of it with this, but found it. Okay. Are you too short? You might need to cover your eye. Other eye. There you go. See the little tiny smudge?
Yeah, you can see like this faintest.
Looks like a fuzzy star, huh?
Yeah.